Right. So we're gonna, in this session, we're gonna show some of the latest development in the Solvent-Botworx product. We'll go through the declarative processing capabilities. In other words, using AI as a kind of declarative engine or as part of a declarative engine. What that means is that we'll use the AI to generate configurations, and then we'll use the tool processing or tool calling features of the AI to process that configuration. The bulk of the functionality would be in the in that implementation. In other words, the tool implementation. So I'll just show what that looks like within the Solvent environment. We'll put out some documentation to get into the nitty-gritty of this. But currently, the way we're handling tools, at least for AI tooling, or AI plugin tooling, is to leverage the existing RAD kit creation feature of a platform. A RAD kit is basically a kind of project, software project, and you can use that. The AI configuration has the ability to point to such an implementation and use it as tooling. The current examples that we have, these are basically reference implementations for the idea of the declarative processing. It covers both doing it on the front end, meaning using the browser side of things to drive it, or doing it on the back end. If you open this up, there's a lot of code in here that does the processing of the configuration that's going to be AI generated. So this is a front end version of it. It does a bunch of things. Again, we're not going to dig into this right here, but engage in the forum and we can discuss it and likely put out some much longer sessions that actually go into the nitty-gritty of this. But this is basically a tool, plugin. You can think of it, an AI tool. The AI will be able to call this tool. There's an entry point. Let's open up the AI configuration just so I can show how things are glued up. If we come in here and first we can go to the prompt. So we have prompts. It's a low code prompt. This is the prompt definition object, and it has references to tools that it uses. Here it says I'm using the default tool. You can plug in as many tools as you want, and the prompt will select the appropriate one. I believe the tools are defined in here. You can move it around when you get access to this. So here's a tool implementation. Here's the default tool. Again, you can have as many of them in there. There's a name, and then there's this FQ name, which is fully qualified name. This has to do with, there's a repository capability in the platform that allows you to define namespaces for software projects, the RAD kit stuff that I mentioned. So this is it's really just an identifier. It uses the kind of the JVM package naming convention. So that's how we refer to our tool, and that basically points to this. There's a whole lot of stuff that facilitates the loading of this, but in the end of whatever that process is, it gets access to this code. The AI gets access to this code. So we have this here, we have the tools. We do have some other ways of defining tools for the prompt. And There's a function called process configuration. If I open up, let's open up the prompt templates here. So this is all using the Solvent object modeling tech, which is really, really powerful. It's great for prompts and managing prompts. You hear people complain a lot about the drudgery of dealing with prompts. Well, if you use this platform, that goes away. So here, there are a bunch of prompt templates in here. For the example that I'm going to try to show, the declarative processing, there are a couple of prompts that prompt templates that we're gonna use. So we'll start with the prompt definition itself. Here it is. And this can refer to other things. So here it refers to the prompt templates that we define. It's a way to combine a bunch of different prompts for your actual execution to the AI. So here we have app-gen rules, which is a bunch of rules for how we're going to generate our configuration. I won't get into this right now, but it refers to it here. We call it a preamble, which is basically to say, it's the basis for the prompt that gets run. And here's another reference to the second prompt. This one represents the actual application. Think of it as what a user would actually write when they want to create an application. So here it is, just plain language. This will then get converted into a declarative configuration. There is a tool description in here, which will be familiar if you are familiar with the AI provider API formats. By default, the platform uses the OpenAI format, but it does, the implementations for Anthropic and Gemini do have, the ability to adapt this configuration to fit their own needs. So here is our tool definition. This will get dynamically injected, and it basically allows us to use this JavaScript, right? So this is process configuration, and here's a function process configuration. That call will eventually, the AI will eventually call this code, which is here you have the this object, a function name, which will map to this stuff, and that's how we're able to call this directly from the AI. And the rest of it is the actual implementation of the declarative processing, meaning we take the configuration that comes in, and then we try to create an application out of it. It's complicated. There's a bunch of supporting functionality to make that happen. And right now what we have is really a reference implementation. It's by no means ready for prime time. It requires a decent amount of work to get something going, but we think this is a good way to anchor the AI, right? Because otherwise you don't really have a whole lot of control over what it generates. But if you have a declarative processing of the configuration, then you can impose your own controls on it. There's a ton of stuff in here that I won't have time for it to demo in this session, but we have plenty of sessions coming down the pike that will dig into it. So let's run a quick example. I'm going to switch to a different tab here so we can run this. I'm going to open a session that we'll use. This is for, we're going to use OpenAI. Again, there's a lot of glue up, but basically we have this set as our output folder. If you look at the prompt definition in here, you'll see a whole bunch of stuff. One of them is the working directory, and this is configured to point somewhere in our directory, if I can find where that is. In any case, I think it's defined on here. Here it is. it's defined here. So basically you can like drag and drop a folder to make it a working directory for your session. And that means, if you have to generate files or do stuff, the AI would know where to save that information, that data or output. So without further ado, I'm gonna select our prompt. We have that menu there that gives us easy access to our prompt. The prompt we want to run is this generate low code application, which is this. We have this already pre-set up. It's going to use this preamble rules for the generation, and then it's going to use our sample application request here, which is just plain English to generate the application. So let's go, and this will take some time, so hopefully it works and doesn't run into the usual issues that we run into, like invalid output is one problem that's persistent, even though we've put in some things, some safeguards, like JSON repair functionality, and we'll continue to work on that. But it's an ongoing issue. So I'll keep the fingers crossed and hope that this whole thing goes through without falling over. So it created the application, and it's gonna create the objects in the configuration now. So just give it some time. There's stuff going on behind the scenes. Eventually when I finish, this output window here will show the result from our AI calls. And we'll get a chance to see what the actual configuration looks like. So this particular run is happening on the front end, meaning there are a ton of calls, like literally hundreds of calls made back and forth to create objects, to set values, and do a whole bunch of things as it's processing. There's a second implementation, which is a back-end based implementation that saves on the back and forth traffic. So as a developer, you will have the choice to decide how you want to implement your tooling, whether you want it to be front-end driven or back-end driven. There are plus and minuses for either approach. So the alternative to declarative processing would be to just tell the AI to generate the app. And we do have, if you look at some of our other videos related to Beautify or React Bootstrap, you'll see examples of that alternative approach where we just rely on the AI to generate all the markup and generate all the necessary JavaScript. So that's an alternative approach to declarative processing, but we think declarative processing is the way to go for reliability and consistency. It requires a significant amount of work because you're not just grabbing output from the AI and using it, but rather you're getting a configuration that you then process deterministically. So you have to essentially implement all the logic. You have to come up with your own concepts and assumptions for how your application is going to get structured. It also means that you'll probably end up with multiple variations of your implementations, right? Different types of applications would require different types of assumptions. But the point is that you have control over ultimately what gets created, as opposed to just relying on output from the AI. Okay, so we finish running our configuration, and here it shows the preamble. The preamble is templatized, so a whole bunch of things get added once we run the prompt. Again, not enough time in here to dig into it, but you see that the stuff that we referenced was included, so we get one prompt that goes to the AI. Now let's load this application and see what actually gets created. Okay, so reading this instruction, create my configuration. It should have a toolbar with blog, technology, about. It should have a view that collects addresses, US address, another view that provides lookup for search, and a third view that's supposed to display data. That third view is not really covered in the declarative processing side of things. But we'll take a look. All right, so here's what got generated. I'm gonna open this in a third browser window. So you can see it in full screen. All right, so here's the app that it generated. Here's a search. Of course, we're working with AI, and reliability is a problem. So, for instance, it's supposed to have a table here that will display the search results. This time around, it didn't do it. It's possible that between various changes, something has changed in the prompt that caused it to stop doing what it was previously doing. We've run this example multiple times. And that goes to our point that you really have to get consistency and reliability. You kind of have to take control of the process of using the AI, which means basically, leveraging the AI's intelligence as opposed to just its output. And this is tied. We have some things in here. This is actually tied to code. Let me see. If we open this up, let's see. Open up the object here. This is for a view-based application. You open up this setup. Yeah, so we have this code here, which is a stub that got injected dynamically into this. Meaning if I click that button, it will call this code and it will add stuff to the database. Of course, this is just local storage. It's not making any network call. But you can dynamically inject this. And if we go to our configuration, our AI config, that code is saved as part of a configuration. If I can find where it is, I believe it's under here. These are all just examples. So, all right, so here's where that code comes from. So it gets pulled dynamically and injected. Of course, in practice, this will probably just be maybe a module loading code instead of the actual module being put in here. You'll have a code that will load your module and make it available as a global object that your application can then use. Let me turn off composition so that we can see the plain code that got generated. So turn off composition here. So we have that turned off, and let's reopen that application, and we'll take a look at the source to see what was actually generated. The page. So this is all just plain view, in this case Vue base code. It means that you can take this and take it anywhere you want. You can include it into other software that you're building. highly portable. You don't have any junk in here that's product specific. There's nothing weird about how it's structured. It's just plain old uh, output, standard output of HTML and JavaScript. Um, you can integrate this into any build process that you have. It should be compatible with all of it, still while using all the powerful capabilities in the product. So here's our code. It got integrated with this. Meaning, again, if I click this button, say 10 test strip, and I hit that, it's calling that code. Unfortunately, it didn't generate the tables for us, so we can't show it, but um, there is the declarative processing has it has a pattern. It captures a pattern for displaying data from the database. Meaning, um, if we do a search, that data got removed, got returned. It'll get bound to the table, and it has the option of clicking on a row, for instance, so that you can see the details of that data. Part of doing declarative processing is to capture those type of patterns and implement them in your tool. That way, that's how you get consistency, right? So if we take a look at a toolbar example here, this particular implementation is for Beautify, so you'll see a lot of Beautify related things. It looks for specific patterns. It looks for things within the configuration. It will prompt the AI back for clarification. So for instance, you have something here called query, where we get configuration from the AI, but we're not sure what's actually in it. We can reprompt the AI with just a portion of the config and say, hey, is there a title in here? Is there a logo in this configuration? If there is, the AI will respond back with the appropriate response and the information that you ask for. And then you can use it in a very deterministic way without the guesswork. So here we have this toolbar implementation, which makes some assumptions about what a toolbar is going to look like. It has some buttons and it has a logo. You can expand it so that it accommodates other things like having a text box or whatever else you want to support. So again, like I said, takes work, but it gives you a huge amount of control. The platform provides the facilities for creating objects and interacting with the object platform, which is very powerful. So that's how we're able to do all of this. We create objects, update them from the configuration, and drive the automation from the AI created configuration. Here's another example of a sidebar implementation. Same idea. We take a config, we make certain assumptions about what that sidebar is going to look like, and then we process the configuration. We prompt or reprompt the AI to clarify certain things in the configuration that we're not sure of. With this approach, it means that the user doesn't have to be rigid in their instruction. They can be fairly relaxed in terms of how they phrase their prompt. And by reprompting, you can clarify, right? So for instance, we're not going to ask the user to use certain labels or certain language, because once you start doing that, it basically means that you're going back to just, programming in effect when you have rigid requirements for the language to use. But by reprompting, meaning we take the configuration, we're not sure, like for instance, what's a title, what's a label, but we ask the AI, hey, here's a config, it has, certain information in it. Can you help clarify, is this a title? Does it do X, Y, and Z? Is this code that asks to do this and that? The AI is fairly good at answering those type of questions, and it will happily respond with information that you can then use deterministically. So here's the actual output that we got. Let me show that quickly before we end this session. I'm going to paste that in here, tool call response. All right, so that's our configuration. Let's see the actual object. And thankfully this time around, we didn't get any error in the JSON output, so we can examine it. Here it has initialization code. which tells it to load information from a database, addresses, and it has description. This is when I mentioned reprompting. This is very helpful because by asking the AI to add description to various object nodes within the configuration that it generates, it allows us to reprompt by using that description basically to reprompt the AI for something more contextually specific to our application. That's how we know, for instance, if a node is an icon, because it could use a different word here. It could use something else that's not clear to us when it sets this attribute. It's not going to use icon. It could use image. It could use avatar. If you're familiar with AI, it's very inconsistent in that way. So you need a way to clarify things, and combining descriptions and labels and reprompting based on a particular context of something that you're looking for is a powerful way to clarify your configuration without requiring the user to be rigid in how they do their prompting. So here's our config. It has a bunch of things in here. I didn't get into the detail of what the configuration preamble prompt looks like. Let's see. It has a lot in it. Right, so here it has a bunch of stuff in here, but we don't have time to dig into it. We'll have more sessions that dig into what this means. This is very sensitive. Sometimes even just changing one word can radically change the configuration that gets generated. So your job as a developer who uses this platform would be to massage this type of stuff and make sure that it's doing what you want it to do. We have really nice prompt management features, everything from things like commenting out portions of prompt to, of course, injecting different tidbits for different places. Here we have type definitions that we import. You can import other data. We import information about our module object, what it looks like, what functions it provides. That helps the AI when it's generating code to glue up your application. Hopefully this is enough to get a sense of what we mean when we talk about using AI for declarative processing. There's a lot more to come on it. Thank you very much.